Hi guys, this is additional mathematics form 5 textbook question for chapter 5 probability distribution summative practice. My name is Terry. If you enjoyed this video, kindly like, subscribe, and also give us comment on how we can improve this video presentation. So again, let's go straight to this question now. Now here we have two fair dice. We toss it at the same time. Okay, A and B represent the number on the surface on the dice that is recorded. So X represent the score when A plus the score of A plus B when A is equal to B. So for me, I will list out like this. You don't have to necessarily draw this, but I just want you to know that when you toss a fair die, you have 6 possible outcomes. Like your A, you can get 1, 2, 3, 4, 5, 6, and B, we also can get 1, 2, 3, 4, 5, or 6. Now, when A is equal to B, you must have the same value. Like for example, you get 1 and 1, so the sum is 2. Or you get 2 and 2. A, you get 2. B, you get 2. The sum will be 4. 3 and 3, the sum will be 6. 4 and 4, the sum will be 8. 5 and 5, the sum is 10. 6 and 6, the sum is 12. So X is actually a discrete random variable representing the sum. So your X in this case will be 2, 4, 6, 8, 10, or 12. Okay, so I just thought it's better I list out so you can understand how this thing works. Okay, all right, but it's not necessary to draw this table here. All right, let's go straight to question number 2. So here we have a table that shows the probability distribution of a discrete random variable. So the first part, find the value of Q. Now we know that in order for this to be a discrete random variable, the probability distribution means in this case the sum here must always be 1. So let's take 1 over 12 plus 5 over 12 plus 1 over 3 plus Q, and let this be 1. So 1 over 12 plus 5 over 12 is 6 over 12. 6 over 12 is actually 1 over 2. 1 over 2 plus 1 over 3 is 5 over 6. Okay, and your Q will be 1 minus 5 over 6, which is 1 over 6. Okay, for part B, we want to find the probability of X more than 2. More than 2 means it's either 3 or 4, right? So we can say X greater than 2 is now the probability of getting 3 or 4, which is 1 over 3 plus Q, 1 over 6. Answer is half. Okay, moving on to question number 3. So here we have a school that implement a merit and demerit system. I'm not sure whether the school actually do that. Alright, so in this system, each pupil will be given 2 points if he behaves well and -1 point if he behaves badly for each week. So a plus represent good behavior, minus represent bad behavior. So we're supposed to construct a tree diagram, right, for the period of 3 weeks. So that means we have 3 branches. So number 1, you can have good behavior. Okay, let me move this down a little bit because you need a bit of space. Yeah, so we need a bit of space. So I probably start from here. Good behavior is a plus, bad behavior is a minus. Good behavior is a plus, minus, plus, minus, plus, minus, plus, minus, plus, minus, plus, minus. So this is your week 1, yeah, week 1, week 2, and this will be week 3. Okay, and your outcome, for example, in the first week, you can have plus plus plus. In the first week you get plus, second week plus, third week plus, so you get triple plus. Or you can get plus plus minus, plus minus plus, plus minus minus, minus plus plus, minus plus minus, minus minus plus, minus minus minus. Okay, so now you also need to know that your X in this case, we need to list up X value. Because part A we want to construct a tree diagram. We're done actually part A, but part B we're finding X represent the point received during 3 weeks. So if you get 3 plus, meaning each time you get a positive behavior, yeah, behaves well, you get a plus 2 point. So if you have plus plus plus, your outcome X will be 2 plus 2 plus 2, which is 6. If you get plus plus minus, you should get 2 plus 2 minus 1, right? 2 plus 2 is 4, 4 minus 1 is 3. I don't think I have to write down for you. Okay, if you want to understand how I get this, is 2 plus 2 plus 2 for the first part, 2 plus 2 minus 1 for the second one. Third one is plus minus plus. Now, actually plus plus minus and plus minus plus are the same because you have 2 positive and 1 negative. So you're still getting 2 times 2 minus 1, which is still 3. For plus minus minus, you're getting 2 minus 1 minus 1, which the end result is 0. Minus plus plus is the same as plus plus minus, which is 3. Minus plus minus, 2 negative, 1 positive is still 0, right? So it's the same as this, 2 minus 1 minus 1. And the next one is minus minus plus, again, same, 0. Minus 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 is minus 1 minus 1 minus 1, which is minus 3. Very bad behavior. All right, so here x can have a few outcomes. The smallest value of x is negative 3. You can get negative value in this case. Yeah, you behave badly for three weeks. 0, 3, or maximum is 6. Yeah, be a good boy, you get 6. Bad boy, negative 3. Okay, right? So this is okay, right? Not difficult. All right, moving on to question number 4. So in a game, a player is required to throw 3 tennis balls into a basket from a certain distance. Each player is given 3 attempts. The probability that a player succeeds in throwing a tennis ball into a basket is 0.45. Okay, it's a very long question. Yeah, so number 1, we are supposed to show that x is a discrete random variable given x represents number of times the tennis ball entered the basket. So here, if you're supposed to show, that means you have to find the probability and show that the sum equals to 1. Okay, now we cannot assume at this stage, we cannot assume and say, oh, this is a binomial distribution, so we just use a binomial formula. So because if you assume it's a binomial distribution, then it's already a discrete random variable, right? So in this case, if they ask you to show, you need to start from scratch, as in we start from a tree diagram. So here we have to start off by drawing a tree diagram like this. Let's say if he score, I'm going to call it S. He miss, I'm going to call it S with a bar. You can write M for miss. Then this is S score, miss, score, miss, score, miss, score, miss, score, miss, score, and miss. Great. So the chances of you scoring is 0.45, missing would be 0.55, and so on. So I know this is very annoying, lots of things to write, 0.45, 0.55, yeah. Okay, I'm done with this. Now the next thing is, okay, this is 55, yeah. So the next thing is we have to list out week 1, first attempt. This is like first time. This is the second attempt. Sorry to squeeze everything in here, and this is your third attempt. Okay, and you have your outcome here. Let me write down nicely. Your outcome is over here. You can have score, 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 miss, score, miss, score, score, miss, 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 score, score, miss, score, miss, 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 score, miss, miss, miss. So there are 8 outcomes. So I hope you know if there are 2 possible outcomes and you do it in 3 attempts, it's 2 power 3, which is 8. You should always have 8 possible outcomes. So then we look at the first one. So x represents the number of times the ball entered the basket. So this x will be 3, 2, this will be what? 2, 1, 2, 1, 1, and 0. So let's find the probability x equals to 3. Now x equals to 3, as you can see, we score 3 times, so it's just 0.45 power 3. Use your calculator, you get 0.09125. Now 91125. Now in this case, I use more decimal point because I think if you round off, then sometimes the sum may not be exactly 1, so it's better to write everything. And for x equals to 2, you can see there are 3 cases. Let me highlight for you. 1, 2, 3. 3 cases that where you get x equals to 2. So this will be 3 times score twice, miss 1, 0.55. So this will be 0.334125. Okay, x equals to 1. Let's see. I'm going to use blue color here. 1, 1, 1. There are 3 cases again. So this will be 3. Score is 0.45. Miss is 0.55, but you missed twice, so you times 0.55 times itself, so it's 0.55 squared. Now I've got 0.408375, and lastly x equals to 0. This will be 0.55 power 3, answer 0.166375. 5 power 3 because you miss all three, miss, you multiply together. Okay, I think I need to calculate the probability. The sum of probability would be first one 0.091125 plus 0.334125 plus 0.408375, 0.166375. When you add up, this sum equals to 1. So if I can show that this is 1, so therefore, yeah, x is a discrete random variable. Right, sorry, I just used short form DRV, a discrete random variable. Okay, so I need to list out the possible outcome in the table, draw the graph. Okay, so this time I will draw the table here. Alright, hope you can see. Try to squeeze everything in. So you have 4 possible outcomes, and I think we don't have to write so many decimal points this time, because for the graph, no point writing too many decimal places. So this is x equals to r, bx equals to r 0, 1, 2, 3. For missing all, it will be 0.1. Missing all, that means 0.1664. Scoring 1, 0.4084. Scoring twice, 0.3341. Scoring 3 times, 0.0911. I think it's enough, 0.0911. Okay, sorry for the ugliness. So let's move this up. I'm going to draw the graph now. My largest is actually 0.4 something. So yeah, I'm using freehand. Sorry if my line's a bit not so straight. So this is 0. This is 0, 1, 2, 3. X equals to r. This will be 0.1, 0.2, 0.3, 0.4, and this will be 0.5. So this is your probability bx equals to r. Alright, for x equals to 0 is 0.1665. Now you can't possibly read such an accurate value, so you either read 0.16 or 0.165 or even 0.17. Maybe 165 we can do 165, but it should be in between. So 6.5 boxes should be around here, right? Draw a straight line down. For x equals to 1, 0.40408. That means we can think 405 here. Yeah, between 40 and 41. So over here, draw a line down. And next one, 0.33433. 334 is closer to 335. I can put in between, yes. Yeah, you can read up to half of the smallest box, yeah. So, and lastly, for x equals to 3 is 0.09, less than 1, 0.09 is here. Okay, there you go. That is my graph. I'm done. Okay, moving on to question number 5. Okay, this is a binomial distribution, right? Remember, when they write in this notation, this is n and the second one is p. Probability of success. So n is the number of trials. So the first part we are finding x exactly 2. So use the formula 6c2 p power 2 q power 4. Use a calculator, you get 0.3110, right? Okay, for part B, you are finding x more than 4. So in this case, because your maximum is 6, right? So we will just use 5 and 6 add together, right? So for 5, we write 6c5. I hope you're okay with this formula. Bx equals r is ncr p power r q n minus r. But n is your number of trials, p is probably a success, q is probably a failure, and r is, in this case, whatever probability that you want. You want x equals to 5, so your r will be 5. So your p probability of success in this case is 0.4 power 5. Q is probably a failure, yeah, not successful. So 1 minus 0.4 is 0.6. 6 minus 5 is 1. Then next one is 66, 0.4 power 6, and this will be 0.6 power 0. Now use your calculator. I will get 0.04096. Now I always give my answer correct to 4 significant figure, right? But sometimes the textbook use 4 decimal, yeah, which is okay to use 4 decimal. Just so you know, a textbook give this answer. This is from the textbook. Okay, so it's okay to give more, but don't give less than that. Yeah? Don't give like 2 decimal or 3 decimal. All right, so last one, px less equals to 2. Okay, if you talk about less equals to 2, we are referring to 0, 1, and 2, right? It can be equals to 2. So now some people may even take 1 minus 3, 4, 5, and 6. Up to you, but I think it's a bit more work. So we'll just write 6C0, your P is 0.4 power 0, Q is 0.6 power 6. Now, if you want to avoid mistake, right, it's actually better to write one on top another so that you can see there's a pattern here. 6C1, 0.4 power 1, 0.6 power 6 minus 1 is 5. Then 6C2, 0.4 power 2, 0.6 power 6 minus 2, which is 4. Just add them up. My answer is 0.5443. Okay, all right, I think this is okay, right? Now let's move on. Question number 4. Okay, the probability that a housewife buys the W brand detergent is 0.6. So that means my X, okay, is a binomial distribution. All right, a sample of 8 housewives. That means my N is 8, right? My probability of success 0.6. Now again, if you don't want to write this, it's okay. I just reference that. If you want to write N equals to 8, P equals 0.6, it's okay. It's the same thing, right? Now find the probability that exactly 3 housewives buy W brand detergent. So I want to find X equals to 3. The formula is N, which is 8, C3, P is 0.6 power 3, Q is 1 minus 0.6 is 0.4 power 8 minus 3, which is 5. All right, type this in your calculator. I'll get 0.1737. Yeah, correct to 4 decimal or 4 significant figure. Now the next one, more than 4. Okay, more than 4. More than 4 means 5, 6, 7, 8. Now if you want to use 1 minus as a lot, because 1 minus 0, 1, 2, 3, 4, it is a lot. Yeah, so we'll just take 5, 6, 7, 8. Right, so this is an unfortunate thing. You have to list out one by one. 8C5, 0.6 power 5, 0.4 power 3. Yeah, 8C6, 0.6 power 6, 0.4 power 8 minus 6 is 2. 8C7, 0.6 power 7, 0.4 power 1. Lastly, 8C8, 0.6 power 8, 0.4 power 0. Now if you have the 570, the class width calculator, the black calculator, you can actually calculate this directly. But that will be another video. Yeah, so I can't show you here. So this is 0.5941. Okay, can? All right, moving on to question number 7. Okay, in the survey, it is found that 18 out of 30 college students have reading as their hobby. So 9 students are selected at random. Find the probability that exactly 4. Okay, so again, it's a binomial, but maybe I work out the probability first. When we say 18 out of 30, that means the probability of choosing a student randomly that likes reading is 18 over 30 is 0.6. All right, your N equals to 9. Okay, because I'm choosing 9 students. So the first part, exactly 4 students. So we can write 9 choose 4. P is 0.6 power 4. Q is 0.4 power 9. I wonder why they keep using 0.6, 0.4. Yeah, sorry, 9 minus 4. I made a mistake here. 9 minus 4 is 5. So calculator, 0.1672. Okay, second one, at least 7. So at least 7 means we are talking about 7, 8, or 9. So 7 will be 9 choose 7, 0.6 power 7, Q is 0.4 power 9 minus 7, which is 2. Then 9 choose 8. This will be power 8. This will be power 1. And 9 choose 9. This will be power 9. This will be power 0. Again, use your calculator. 0.2318. So I would say binomial is the easiest among all three parts of this chapter. Yeah, much easier than normal distribution and as well as the discrete random variable. Okay, next one. A farmer, question number 8. A farmer picks mangosteen at random from an orchard. The probability that the mangosteen has worm is 1 over 5. So P equals 1 over 5. Find the mean and standard deviation if of a number of mangosteen with worms in a sample of 35 mangosteen. So this is a binomial. Remember, mean is mu equals to np. My mu is, n is 35, p is 1 over 5. Answer is 7. That means on average out of 35, 7 of them will have worm, right? But for standard deviation is given by square root npq, right? My n is 35, p is 1 over 5, q will be 4 over 5. Remember, p plus q is 1. So you want to find q. 1 minus 1 over 5 is 4 over 5. You can use your calculator. This is 5.6, and when you take the square root of 5.6, you get 2.366. Alright, that's number 8. Moving on, number 9. So here we are given mean. Yeah, in a group of teachers, the mean number of teachers who own a local car is 7, yeah, and variance is 2.8. So yeah, mean equals to 7, variance equals 2.8, right? So mean is given as np, so I'm just going to sub in np and call this equation 1. Variance is given by npq, and this will be 2.8. Call this equation number 2. So we have to find the value of p and q, or even in this case you don't have to find n. You don't have to find n, right? Wait, let me see. Yeah, you don't have to find n. All right. In this case, actually, the question is a bit weird because your n is not a whole number. If you, I think so. I think this is a question that n is not a whole number. Anyway, let's just do this first. Yeah, I will take equation 2 divide equation 1. So npq divided by np is 2.8 divided by 7. So you can cancel out. Let us cancel out np and p. What's your q? My q equals 0.4. Do you need to find n? No need. We just need to find p. Sub in, okay, I don't want to use sub. I'll just say p plus q. Since p plus q is 1, p is 1 minus q, 0.6. So what we're saying is this. On average, right, there are 7 teachers who owns a local car. Variance is 2.8. So your probability that a teacher, right, selected randomly, a teacher owns a car, a national car, a local car, is 0.6. But the second one is 2 randomly selected teacher. So we don't have to use binomial formula because, yeah, you can say the probability that they own local car is now 0.6. If 2 persons selected randomly, so it's local and local. A simple probability will do. Don't have to use the binomial distribution. 0.6 times 0.6, answer 0.36. Yeah. Now you can even use fraction. You can write 3 over 5 if you like, or this case you can write 9 over 25. Yeah. I think the textbook gave answer in fraction, but it's okay to leave it in decimal. All right. Let's move on to question number 10. This one involving normal distribution, and you notice I actually split them into 4 parts here. Okay, the first one. Okay, x is normally distributed with mean of 48. Your variance is 144. Remember, if they write in this notation, right, this is your mu, this is your variance, so you have to square root 144. Find the square root of 144, you get 12. 12 is your standard deviation. Okay, the first part, I'm finding x more than 47, so I'm going to standardize straight away. Remember the formula for standardization, in case you don't remember, z equals to x minus mu over sigma. X is a random normal distribution. To be able to calculate this using a calculator or even a mathematical table, we have to convert it to a standard normal distribution first. And when you convert this, yeah, look at 47, we're going to minus the mean 48, divide by your standard deviation 12. This will give us PZ greater than negative 1 over 12. Okay, I want to give you two versions because now what I found is that the textbook actually uses the calculator directly, right? That's why you may have a slight difference in your answer. All right, so I will just write this, PZ greater negative 0.083. Now for those who use calculator directly, you can actually type this directly, yeah? Okay, depending on which model you're using. If you're using the gray calculator, right? So you press mode SD shift 3, you look for R, okay? If you're using the mathematical table, yeah, we have to read from the table itself. So by the way, let me do a sketch for you. This is actually on the left hand side, okay? So I think I will base on decimal, yeah? Most of the time I like to use based on 3 decimal places because your mathematical table can read up to 3 decimal places. So maybe I draw it down here. You can see this is on the left, negative 0.083. More than is over here. The problem is your table, your mathematical table, is based on the upper tail, not the lower tail. So what we can read from the table is only the smaller side. So we have to do 1 minus, and we take this part and flip it over 0.8083. 0.083, yeah? 0.083. So this is 1 minus PZ more than 0.083. You can use 1 minus PZ more than half, 1 over 12, sorry, not half. So if you use a mathematical table, you will get 0.4668, right? And this answer is 5332. Okay, so in this case, the same. I think if you use a calculator directly for 1 over 12, yeah, you still get the same answer as 0.083. Okay, but sometimes the answer may be a bit different. All right, B. The P value, your probability is between 38 and 46. Okay, in this case, we take 38 minus your mean 48 divided by standard deviation 12. This is Z. 46 minus 48 divided by 12, and this is your K value. The whole thing is K. I don't write K one more time. So this is between negative 5 over 6 and negative 1 over 6. Yeah, remember, if you're using mathematical table, you cannot read 5 over 6. You have to read the decimal place, and again, it's up to 3 decimal places. So the first one is 0.833. This is now negative 0.167. Okay, I'm going to do a sketch. Okay, let me sketch it over here. Now notice that both are negative. One is negative 0.833, another one is negative 0.167. So it's in between these two values. So we need to flip over to the right hand side, and always remember we can only read the upper tail and we can only read the positive value. So the bigger one will be 0.167, the smaller one will be 0.833. The bigger the Z, the smaller the area, yeah, for positive side. Okay, so in this case we write BZ more than 0.167 minus BZ more than 0.833. Now this is based on mathematical table. I get 0.4337, 0.2024. This will be 0.2313. Now those who use calculator directly, right? Okay, it will be, let me squeeze in here, or Z more than 1 over 6 minus Z more than 5 over 6. Your answer will be slightly different. It's 2315. Okay, yeah, 2315. Okay, I think I don't have to show you more. If you use your calculator directly, you get 2315, which is the same as the textbook's answer. Yeah, textbook answer gives us 2315. Is because I think they do directly, yeah, with the calculator instead of using the mathematical table. But the choice is yours, up to you, whether you want to use find the z first in decimal, 3 decimal places, use a mathematical table, or you want to use directly. Yeah. Okay, so next two. Okay, for part C, again we standardize first. This will be less than. Oh, by the way, there's no difference between equal sign, less equals, let's say this, and this. They are actually the same. I hope you know why, because let's say I use the number 1, let's say 1. The reason is because when you talk about, let's say z less equals to 1, we're talking about this area, right? Less equals to 1, we are talking about this area, does not include 1. But the problem with, if I ask you to find probability z equals 1, is actually a 1 thin line, area under the graph for 1 thin line. What's your area for 1 thin line? 0. So in normal distribution, the probability of z equals 1 is 0. So there is no difference between less equals and less than, right? Understand that? But for binomial is different. Binomial definitely different. Okay. Now I will just drop the equal sign here. I'll write 49.5 minus 48 divided by my standard deviation 12. This will give us, when you standardize it, 0.125. Okay, let me do a rough sketch. 0.125 is on the right hand side, but I want less than. If you want less than, you got to do 1 minus. Remember, your table can only read the upper tail, yeah, the right hand side. So this is 1 minus bz more than 0.125. So it's 1 minus 0.4503, and my answer is 0.5497. Okay. Now, let's look at D. Again, I standardize first. Now, I think for part A, we have 47, so I don't want to rewrite this. If for part A, when you standardize 47, you get negative 1 over 12, so I'm not recalculating this. So 50 minus 48 over 12, this one I'll calculate for you, will be now negative 1 over 12 or 1 over 6. Okay, again, I show you two versions. This is the one with decimal. The other one, the one above, is the one with fraction. Okay, so in this case, you can see that it's between one negative value, negative 0.083, and one positive value, 0.167. Yeah, 0.167. So if it's in between this, right, you have to take 1 minus, minus the left, which is 0.083, and you minus the right hand side, which is 0.167. So we can write this as 1 minus bz greater than 0.083 and minus bz more than 0.167. Okay, use your mathematical table. I got 0.4668, 0.4337, and 0.0995. By the way, you can also use this directly using calculator. Guys, you can actually use this. If you don't want to use mathematical table, you type in the calculator 3 decimal point, your answer will be the same as using the mathematical table, right? But if you use this 1 minus bz more than 1 over 12, yeah, this is, if I leave it as fraction, then your answer might be a little bit different, right? Yeah, I think in this case it's the same, 0.0995, yeah? But sometimes you may have a different answer, as you know, in the earlier part that I've shown you. Okay, in part B, part B, I think the answer is a bit different. Okay, so let's move on to C and D. This is the one that's more difficult, working backwards. Okay, now the reason why working backwards is a bit difficult is that because we do not know where's the position of K. Like for the first one, right, Bx greater than K, number one, you have to standardize this first. We change from X to Z. That is K, you must minus your mu, divide by your standard deviation 12, you get 0.615. Alright, so here's the thing I always teach my students. I always tell them, look, number one, you got to fix the position. What do I mean by fix the position? We do not know whether this K minus 48 over 12 is on the left or on the right hand side, right? So we fix the position, okay? So let's say I just think, but I put on the right hand side, K minus 48 over 12. Number 2, I shade the region. Now, where you shade depends on this symbol here, more than. More than means here. Now, my question is, number 3, we check. Does this probability match the area under the graph? You see, your probability is more than half, but your area is less than half. So it doesn't make sense, right? So I know this is wrong. The diagram doesn't match the question. So I'm so sorry, we have to repeat step 1. So here I fix on the right. Now I know it's not supposed to be on the right, it's supposed to be on the left. So when you fix, it's like there's only 2 options, either left or right hand side, right? So we fix on the left. This is k minus 48 over 12. Now since it's more than, I shade the right hand side. Okay, you check, can this be 0.615? Yes, the area is more than half, the probability is more than half, so it makes sense, right? Okay, the next question is this: how do you find k? All right, we have to do 1 minus. Now if you find 1 minus a bit annoying, right guys, you can do it in a shortcut, as in we know that the total area under the graph should be 1. So I don't want to use a different pen, I'll just right here. Now take 1 minus 0.615. What do you get? 0.385. So this area should be 0.385. Correct enough? Now you read from your mathematical table, right? When this is 0.385, what is your z value? Okay, so if you don't have the black calculator, the class width calculator, then you have no choice but to use a mathematical table. And if you use the mathematical table, guys, you will get 0.20292. Yeah, 292. I hope you know how to read from the table. If not, you get the class width calculator. You press shift 7 probability, then you press 3, then there's an inverse norm. Yeah, you key in your area 0.385, then you press equals, then they will show you the z value, but the calculator will give you negative, but don't bother about negative. It will give you negative 0.292 because the calculator is based on the lower tail. Alright, maybe I have to do another video to show you how to use the calculator. But anyway, coming back to this question, we know that this is on the left. Yeah guys, this is on the left, but this is on the right. So what do? We have to flip them. So we know k minus 48 over 12 should be negative 0.292. Yeah, because they're symmetrical, right? You can flip them over. So now you use your calculator. Yeah, you take 48, bring over 48 minus 0.292 times 12. My answer is 44.50. Yeah, very interesting, right? Okay, B, again I standardize first. 45, you minus 48 divide by 12. This is Z, k minus 48 divided by 12, 0.428. Okay, when you standardize this, this is 3 over 12, negative 0.25. This is your z value, k minus 48 over 12. This is 0.428. Okay, again I want to do a rough sketch. Okay, so I'm doing a sketch like this. I know negative 0.25 should be on the left. Now here's a question. And some people may say, oh, shouldn't this be on the left? Right, I know it's not going to be on the left because negative 0.24 is very close to 0. 0.25, very close to 0. Now, can this area be like 0.42? That's quite impossible, right? So we know that this k value, k minus 48 divided by 12, should be on the right hand side. So that this area can be 0.428, right? So it has to be on the right. Huh? Now, the next thing is, okay, can we find out what is this area? Okay, this part here, up to you. Now, I don't want to write too many steps because I'm afraid you'll find this difficult, more complicated. So I'm just going to do z more than 0.25. Use your mathematical table, you get 0.4013. We know this is 4013, correct? Now, how do you find this part here? Okay, but if you really want to write properly, right, guys, you can do this. Like you can do say, okay, 1 minus bz more than 0.25 minus bz more than k minus 48 divided by 12 equals to 0.428. You can write like this, okay? And this is 0.4013. This is z more than k minus 48 over 12. equals 0.428. And this area, when you do 1 minus everything, right, it will give us 0.951. Okay, here's the problem. 951. Okay. Sorry, I think I wrote wrongly. This is 0.1707. Sorry. So this part here is 0.1707. Okay. Now, anytime your PZ, guys, if your PZ more than number is more than 0.5, you need to do 1 minus, because your area supposed to be on the right hand side before you use the mathematical table to find the Z value. Yeah, and if it's on the right hand side, this area should be less than half, right? So if you use your mathematical table, this is 0.1707, work backwards, right? Find the Z value. My Z value should be 0.951. But here, if you look carefully at your table, you have two possibilities. It can be 951, 952. So which one do I use? Okay, that's an interesting question. Actually, in this case, both can also work. If you have two values, you can take both, or you may want to take in between. All right. But if you want super accurate answer, use your calculator, class width calculator. You will get 951. Yeah, the answer is supposed to be 951. So we know k minus 48 over 12 is 0.951. So I multiply over. Okay, I take 12 times 0.951 plus 48. I will get 59.41. Now, if you use 952, I think you get 59.42. I think textbook gives this answer because they used 952. Yeah. So just so you know, because there are two possibilities. Okay. All right. Let's continue with part G. So okay, this is another issue of this question is that I think there's a mistake in the textbook, because I think the intent is to find the two tail, yeah, because there's no point to have x more than modulus k, because modulus is always positive, right? So yeah, there's no point of having a modulus here, right? I think the intention, and I double check the answer, right? I think the intention is they want your value to be in between here. All right, so for this question, guys, I just want to highlight to you, I think a better question will be p x minus 48 more than your k, right? More than your k. So that means your mean is already 48. This is 48 plus k. This is 48 minus k. You want more than, that means it can be here and here. Remember, modulus more than is the 2n, right? So when you standardize this 0.435, this will be, we take z, I can write modulus z now, right? Because this is going to be, when you minus, k minus 48 divide by your standard deviation 12. This will be, should I call this d? Oh, sorry, I should write d instead. Sorry, guys. This is already minus 48. So your k will be, already. Should I just minus already? I already x already minus. This is already minus 48, right? So so you just have to divide by your standard deviation. So divide by 12. So it should look like this. This is 0.435. It's very difficult to have a modulus question with the x not standardized. If the x is standardized, it's okay. Like for example, when you say z modulus more than 1, so what we are saying is that this is your 0, 1, -1 more than is here. But this is before you standardize it. It's still x, so you have to standardize it, right? So I have to use minus 48 because it's already minus. I just have to divide by the standard deviation to get z. Yeah, this is x, right? You divide by standard deviation. You already minus 48. You just divide 12, correct, to get your z. Okay, so that's why I think this should be the the right notation. Okay, later I'll show you the answer and why it is so. Okay, now I standardized already. The next question is, what do? We know these two parts combined together, right, will give us 0.435. Okay, so let's take half of it, or should I say 2 times this more than k minus 12 equals to 0.435. When you divide by 2, this should be 0.2175. Now you can read from your mathematical table, when this is 2175, this value over here is 0.781. So we know k over 12 is 0.781. K is 9.372. Now the textbook answer at the back, they are actually finding this, right? But we shouldn't say modulus x more than k, I think. So if you take 48, you plus 9.375, then you get 57.37, which is the answer given in the textbook. Yeah, they want you to find the bigger part of it. So that's why I think this question is a bit hard for them to, I mean, it's a bit long to write like this. So I guess it's better to write bx minus 48 modulus greater than k, and you're supposed to find the k value. K is the difference between the mean, either 48 plus k or 48 minus k, right? Is the area at these two ends. Okay, all right. Now let's move on to part h. So again, we standardize. This is minus k. Okay, another thing I'm thinking, why they put minus k? Should use k actually, but since they put minus k, so never mind. I'll just follow minus mean, which is 48, divide by standard deviation 12. Your mean is already 48, so 48 minus 48 is just 0.2578, right? So I will do a rough sketch. So I know this is minus k minus 48 over 12. So this is your in-between value, yeah? And if this area is 0.2578, I know this end I can find, right? Pz less than negative k minus 48 divided by 12 should be what? 0.5 minus, isn't it? 0.5 minus, which is 0.2422. 2422, right? Okay, I hope I didn't make any mistake. 2578. Yeah, 2422. Okay, now if you look at the mathematical table, 2422 is actually 0.2422. Your z value is 0.699. But this is on the right, so we're going to flip over. So negative k minus 48 over 12 should be negative 0.699. Okay, you can calculate this directly. Maybe I cancel negative. K plus 48 over 12 is 0.699. K will be times over, bring over negative 39.61. Now I feel that k shouldn't put a negative in the first place, because yeah, it's better to think this is 48, right? That means this is 39.61. There's no point putting a negative in front, right? But because the question already have a negative, that's why we need to add in a negative, and your answer will be negative 39.61. Yeah, we know it's on the left hand side of 48. It should be 39 point something, right? Okay, such a long question. Let's move on to number 11. Okay, it is known that the IQ, intelligent quotient, test of 500 candidates who apply to enter teachers training college are normally distributed. So yeah, here we can write X has a normal distribution. Your mean is 115, standard deviation 10, but here we put 10 square because when you write in this notation, it represents variance. But if you don't want to write like this, it's okay. I just list out mu is 115, standard deviation is 10. Okay, first part. A college requires an IQ not less than 96. Not less than 96 means what? Greater equals 96, okay? But they say estimate number of candidates who do not qualify. Do not qualify means you must get less than 96, right? If you qualify, you must get greater equals 96. Okay, so we standardize this. 96 minus 115 divided by 10. So this is z less than negative 1.9. You can flip it over. This is z more than 1.9. Now again, if you're not sure, negative 1.9 is here. You can't read this, you've got to flip it over to positive 1.9. Yeah. So, and read directly from the mathematical table, you get 0.02872. Okay. Now, you have total 500 candidates, right? We know that number of people who do not qualify divide by size of your sample space represent number of equals to probability of people who do not qualify, right? So you're finding the number of people who do not qualify. You take the probability 0.02872, you multiply with the size of your sample space 500, you get 14.36. We'll just take 14 yeah, to the nearest integer. Yeah, okay. All right, that is part A. Part B, if 300 candidates are qualified to enter, so find a minimum IQ level needed. So okay, let's say the minimum means more than, so you got to understand that minimum means, okay, I need K more than here, right? I don't know, it can be on the left, can be on the right, but we'll just write 300 over 500 first, right? 300 out of 500 of them qualify, so the probability is 0.6. And we can standardize this. This is K minus mu. Your mu is 115, standard deviation is 10, 0.6. Now, if you do a rough sketch, you realize that this K minus 115 over 10 should be on the left. Remember how I say you got to fix the position. If you fix on the right, more than, because more than means to the right, can this be 0.6? Cannot be, right? Because your area should be more than half, right? So the correct diagram should be this one, 0.6. Okay, so if it's more than half, we have to do a 1 minus, or should I write here less than? I write here, this one is z less than K minus 115 over 10 is now 1 minus 0.6, which is 0.4. Now, if this is 0.4, we have to read from the mathematical table. The problem is your mathematical table is based on the upper tail. When this is 0.4, this is 0.253. Now, when you take this and you flip to the left, because K minus 115 over 10 is on the left, you need to put a negative here, because you need to flip this to the left, right? So there's a negative, right? And still 0.4. Now you find K115 minus 0.253 times 10. I got 112.5, correct to 4SF, right? I think the text will give us 47. Yeah, I think the text will give us 47, but for me, I always give my answer correct to 4 significant figure. So if you give more, it's not an issue. So I just use 112.5. Okay. All right, let's look at number 12. Okay. Now here a body mass check. Yeah, is performed on worker in a factory. The body mass of the factory workers has a mean of 65. Your variance is 56.25. You need to find standard deviation from variance. So when you square root this, square root 56.25, I got 7.5. Okay, next they say there are 250 workers with body mass between 56 and 72. So we write 56, 72. We standardize this minus your mu, divide by your standard deviation. 72 minus 65, divide 7.5. So this is negative 1.2. This is 0.933, right? I'm using decimal. I'm just using decimal. We know that this is supposed to be 1 on the left, 1 on the right, and it's in between. So when it's in between, you do 1 minus 0.933 and 1.12. So we write here 1 minus b, z more than 0.933, z more than 1.2. This will be, use your mathematical table or calculator, 1151. And okay, 1151 is the other one. Sorry, 1151 is the 1.2. So this is 1754 and 1151. I got 0.7095. Okay, but this is just a probability. I want to find number of worker, right? So number of worker with this certain mass, I'm just using short form. Certain mass is m, divided by size of your sample space, gives us the probability of worker with this mass, right? Now, my number of worker with this mass is 250. My sample space, I don't know. My probability is 7095. Okay, so we take this ns, bring up, take 0.7095, bring it down. My size of your sample space, that means the total number of factory worker will be 352.36. In this case, we round off to 352. Always take the nearest integer. Alright, that is part A. So part B, if 5% worker are obese, find the minimum body mass. Okay, 5% obese, X more than, let's say the cutoff for obese will be K equals to 0.05, 5%. Here, this is quite clear cut. It's on the, it has to be on the right hand side. We know that K should be here, yeah, because it's a top 5%, 0.05. Now we have to standardize this first. K minus mu. My mu is 65, standard deviation 7.5. This is 0.05. Okay, now use your mathematical table, right? You will get, okay, if you read from the mathematical table, when this is 0.05, my z value is 1.645. Okay, so K minus 65 over 7.5 is 1.645. So calculate, yeah, times it over plus 65, or you can write this down if you want. So my K value is 77.3375. I will just round off correct to 4 significant figure. Sorry, it's 334 kg. Okay. All right. Okay, I think we got 2 more to go. Question number 13. So an orchard. Well, this one I need some space. Need a bigger space. Okay. An orchard produces oranges. The table shows the grading of oranges to be marketed according to their masses. So it's given that mass of orange produced normally distributed, mean of 260, standard deviation of 35. Alright, so A, if an orange is chosen at random, find the probability that it is from grade A. Okay, so to find grade A, we know the probability, your X must be more than 300, right? So we change from X to Z minus your mu, guys. Your mu is 260, standard deviation is 35. Use your calculator. I'll get 1. Okay, again, I think your textbook uses a calculator, so they use 8 over 7. If you use decimal 1.143, this will be 0.1265. But if you use 8 over 7, you will get 1266. Yeah, just so you know. So both are actually the same. Yeah, correct. Okay. Let's look at B. I'm finding a number of grade B oranges in a basket of 600. Yeah, so let's find out the probability of grade B first. In this case, between 200 and 300, you can see grade B is between 200 and 300. 200, you need to minus 260 divided by 35. Now 300 don't need to re-standardize because we know it's 8 over 7, right? So this one, I think I use decimal, guys. I think if you want, you can use fraction. So I think I don't want to write so many steps. Okay, this is why I got 1.143. Now we know this is in between, guys. If it's in between, one is negative 1.714, another one is positive 1.143. I need to do 1 minus 1 minus this 1.714 and minus 1.143. Sorry, a bit ugly. So 1 minus B, Z more than 1.714 and 1.143. So use your calculator 0.0433, or mathematical table also can, 0.1265, and your probability is 0.8302. Okay, maybe I'll move up a little bit. I don't have enough space. Okay, so now I need to find the number of grade B. Remember, number of grade B divided by total. So my total is 600. The probability is 0.8302. So my number of grade B is 600 times 0.8302. And I think we can just round off straight away, 498. Okay. All right. This question is similar to SPM 2006. Yeah. Okay, 99% of the orange can be graded and sold. Find the minimum possible mass. Yeah. Okay, so 99% graded and sold. So I need to know what is the mass, the cutoff for them to be graded and sold, right? So if you know what happened to the length, the mass less than m, I don't know, we don't sell them, we don't grade them, maybe we make juice, right? So we need to, number one, standardize this. This is m minus 260 divided by 35. This is 0.99. Okay, you can see this m should be on the left, right? Should be on the left hand side. So m minus 260 over 35. So that this area, right, more than, remember more than is on the right. Can this be 0.99? Yes. If this 0.99, this should be 0.01. Am I right? So I can write PZ less than m minus 260 over 35 is equal 0.01. The thing is, you need to use your mathematical table and find when this is 0.01, what is your z value. Okay, my z value is 2.326. But remember, this is on the right. The mathematical table is based on the right. But this position here is on the left. So you need to put a negative in front of 2.326 because I need to flip this to the left. Now, take 260 minus 2.326 times 35. My answer is 178.5. Now, if you round up correct to 2 decimal, I mean to the nearest integer, it will be 179. I think textbook use 179. Yeah, nearest integer, and I'll just take nearest integer then. 179. Okay. Oh, I think this is the last one. All right, not the second last. This is the last one. So, guys, again, if you find my videos useful, and you know, if you want to have to get more of our materials and books, you can visit our website or even go to our Shopee account, right? Just search Pusat Tuition Utility, all right? Get the bio modules, our books, all right? Pass your question and so on, right? I hope you learned a lot from this video presentation, all right? I'll see you guys in the next video. Bye.